Do you know what the compass heading is at Howland Island? In this video, I will answer this question, and maybe more. If you have researched the disappearance of Amelia Earhart, then you're familiar with the 157337 heading and the position of the sun. According to Wikipedia, at the equator, from the March equinox to the September equinox, the sun rises within 23.44 degrees north of due east. So this means the sun rises within a 66.56 degree true heading. So let's give this a range of 66.56 to 67 degree true heading at sunrise. I will be putting a link for this in the description below. We also know that a 157,337 degrees and 67 degrees intersect each other at 90 degrees. Did you know a 157,337 compass heading in this case could be represented by both a 67 degree true heading based on the position of the sun and a 67 degree compass heading somewhere near Howland Island? Now, before people start thinking I might be stretching things a little bit, let me ask you this. What was Amelia Earhart's compass heading before turning on to 157,337? We don't know. She never even said. Thanks to TIGHAR, we know that it is about a 78 degree true heading from Lake Papua New Guinea to Howland Island. But what was the compass heading for a 78 degree true heading? We don't know. No one has even given us this information. TIGHAR has also illustrated the angle of the compass heading 157,337. If we were to draw a line 90 degrees from 157,337 and slide that line towards Ley and Howland Island, it would give us an approximate or an idea of the location of a 67 degree compass heading. What I'm going to do is I'm going to calculate the compass headings in this video. In order to calculate the compass heading, we need to find the magnetic declination, or the difference between magnetic north and true north. We do this by going to a magnetic declination calculator. I will be putting a link in the description below for this as well. What we do is we enter the longitude and latitude of Howland Island. So in this case, it's going to be 0.8113 degrees north latitude and 176.6183 degrees west longitude. Okay. We do that. Once we do that, we then enter the date, which will be July 2nd, 1937. We then select calculate, and our magnetic declination for Howland Island on July 2nd, 1937 is a 9.49 degree east declination. So just for fun, I actually did today's date, which is May 15th, 2020. And when I entered all this information, I got 9.79 degrees east. So the magnetic field has moved approximately, 0.3 degrees in 80 years. Okay, so now what this means is a magnetic north is 9.49 degrees east of true north. What this means in our case is we have a 78 degree true heading. Now we subtract 9.49 degrees from 78 and we get a 68.51 degree compass heading at Howland Island. Now, if it's a 68.51 degree compass heading at Howland Island, that means a 67 degree compass heading is just less than 2 degrees north of Howland Island. Now, if we add 9.49 degrees to that 67 degree compass heading, we get a true heading of 76.49 degrees. We can now use this information along with other information like the distance between Ley and Howland Island, which is 2,556 miles or 2,221 nautical miles. To find out, we can do this to find out if Amelia Earhart and Fred Noonan could have been on a 76.5 degree true heading or a 67 degree compass heading. In order to follow along, you're going to have a calculator that calculates right angle triangles. So once we have our calculator open, we insert 2,556 for the hypotenuse and 78 degrees for the angle A, and this will give us a rise of 531, a run of 2,500, and an angle B of 12. What we do now is if we use the rise of 531 and we use the 76.5 degrees for the angle A, we can calculate the distance, or the hypotenuse. When we do this, we get a hypotenuse of 2,274 miles. If you remember earlier, we had two numbers for the distance. We had 2,556 miles, which is equal to 2,221 nautical miles. My question is, what happens if we insert 2,221 as our hypotenuse and 531 as the rise? When we do this, we get an angle A of 76.17 degrees. I find this interesting. What we have to remember is the more decimal places we use, the more accurate our answers will be. So these numbers here that we're using are not quite accurate. When I did this a few years ago, I had to calculate the rise myself. Figured out the latitude distance for Ley to Howland Island. Okay, and how I did this was I first had to find out what was the distance between latitude lines. Latitude lines range from 68.7 miles apart near the equator to 69.4 miles apart near the North and South Poles. I will be putting a link in the description below for this information as well. Now, if we take Howland Island's 0.8113 degrees north latitude, multiply it by 68.7 miles, we get a 55.73631 miles north of the equator. We then take Ley's latitude 6.7155 degrees south latitude, multiply it by 68.7 miles, and we get a 461.35485 miles south of the equator. When we add these numbers together, we come up with a 517 miles. We get 517 miles right here. Okay, and now if we insert 2,221, okay, at the hypotenuse, and we insert the correct rise of 517.09, we now get an angle of 76.54 degrees. So what do we have? We have a sunrise range of 66.56 degrees to 67 degrees true heading on the morning of July 2nd, 1937. We also have a 76.5 degree true heading, or a 67 degree compass heading north of Howland Island, based on a math error. In conclusion, I personally believe that it is possible that Amelia Earhart and Fred Noonan flew 2,556 miles on a 76.5 degree true heading, then turned right 90 degrees onto a 157337 compass heading, eventually running out of fuel north of Howland Island. If you made it this far, thank you very much, and please hit that like button so we can pass this video on to as many people as possible. As again, thank you very much.